Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.1, Problem 20. This is Section 15.1. It's problem number 20. We want to find the integral of 5 over x cubed plus x cubed over 5. So we have the two fractions. One is the inverse of the other, which makes the problem look a little bit interesting. The x cubed over 5 on the right is fine, actually. The 5 over x cubed we have to rewrite a little bit. So let's rewrite the whole thing and put it in a format that's going to be a little bit easier to deal with. So the 5 over x cubed, let's write that as 5x to the minus 3. Because when I solve an integral, I can't have the variable in the denominator. This takes care of that. I bring it up to the numerator just by making the exponent negative. And the x cubed over 5 can be written, if we like, 1/5 x cubed. This way it kind of fits the format that I'm used to seeing. I'll keep it in parentheses. I'll put a dx on the end because that's the way you're supposed to write it. If you have an integral symbol, there should be a dx at the end. So now each piece can be dealt with the way I usually do it. So if there's a number in front of the variable, that's going to go in the numerator of a fraction, and the minus 3 exponent will be in the bottom plus 1. Then you'll have x, and the exponent will be the old exponent plus 1 more. And now the next piece, you have a 1/5 as the number in front. That's okay. You can leave it 1/5 if you want, just like we did with the 5. And then you'll have the old exponent of 3 plus 1 more, x to the 3 plus 1 more. And then there'll be a constant at the end. And that's the answer. Now you can clean it up quite a bit. You don't want to leave it that messy. So the first piece, 5 over negative 3 plus 1, x to the negative 3 plus 1. Let's make that 5 over minus 2, x to the minus 2, which is good. And then the next piece, 1/5 over 3 plus 1, x to the 3 plus 1. Start off by doing 1/5 over 4. X to the 3 plus 1 is 4, plus you have a constant at the end. That's better, but 1/5 over 4, we can do better than that. So that 1/5 over 4, let's think of that as 1/5 over 4 over 1. That's a complex fraction. It's a fraction over a fraction. And what you do is keep the top fraction the way it is, the 1/5. You multiply times the inverse or reciprocal of the bottom fraction, which just means flip it. It comes up, becomes 1 over 4 instead of 4 over 1, and it gets multiplied. So now when you multiply the two fractions, 1/5 times 1/4, the top times the top, 1 times 1 is 1. Denominator times the denominator, 5 times 4 is 20. So the number in that 1/5 over 4x to the 4th becomes 1/20 x to the 4th in a more simplified format. In front of that we had 5 over negative 2, x to the negative 2. It was a plus in between. I have my simplified 1/20 x to the 4th, and then plus a constant. And now that's the answer. And again, do you want to check it? So if we take the derivative of what I claim the answer is, it should bring us back to the original question, or one version of it. So if I do the first piece, 5 over minus 2x to the minus 2, take the derivative, take the exponent of minus 2, bring it down times the number in front, 5 over minus 2. The minus 2's cancel. So you have 5x to 1 less power. That minus 2 drops to a minus 3. So that works. The next piece, 1/20 x to the 4th. Well, the exponent of 4 comes down times the number in front of 1/20. So 4 times 1/20 is 4/20. 4/20 will reduce to 1/5. X to 1 less power, 4th power drops down to a 3rd power. The constant, the number without a variable of any kind, will have a derivative of 0. So it does match.